Today, let's talk about a small IC that does a big job inside power supplies. This chip is called Viper 22A. It is a smart power switcher IC. You can find it in adapters, chargers, TV power boards, and many SMPS circuits. Inside this one small IC, there is a PWM controller and a high-voltage MOSFET. That means it can directly handle high DC voltage from the rectified AC line and switch it at high speed. Its main job is to convert high-voltage DC into controlled pulses for the transformer. Then the transformer and output parts make stable low voltages like 5 volts or 12 volts. Viper 22A also has built-in protections. It protects against overtemperature, overcurrent, and short circuits. That makes the power supply safer and more reliable. Because of this IC, the circuit becomes smaller, cheaper, and more efficient. That's why it is very popular in small SMPS designs. So next time you open a power supply and see Viper 22A, you know this tiny chip is the brain of the switching power stage. Follow the page for more real electronics knowledge. Today, I'm introducing a small but vital component on this PCB. This little blue 3-pin part is a ceramic resonator. It basically acts as the clock or the heartbeat for the whole circuit. If you look at the marking, it says 10.0C. That stands for 10 megahertz. It means this component creates an electrical pulse exactly 10 million times every second. This pulse tells the main chip nearby exactly when to process data and execute commands. Now, why use this instead of a standard crystal? This resonator has built-in capacitors right inside its casing. Normally, you'd need extra parts to make a timer work, but here everything is integrated into one piece. It saves a lot of space on the board and makes the design much simpler. You'll find these in everything from TV remotes to home appliances. They're incredibly reliable and can handle physical vibrations much better than standard glass crystals. It's a simple piece of engineering that keeps our electronics running in sync. If you want to learn more about the components inside your gadgets, make sure to follow this page. I'll be breaking down more electronics very soon. Thanks for watching. Today, we are looking at an IR receiver module. This small black component is used to receive infrared signals from a remote control. When you press a button on a remote, it sends infrared light pulses. This IR receiver detects those pulses and converts them into electrical signals. It usually has 3 pins: VCC, ground, and signal output. Inside the module, there is a photodiode, amplifier, and filter circuit. It is designed to detect a specific frequency, commonly 38 kHz, which is used in most remote controls. Applications include TV systems, air conditioners, home automation devices, microcontroller projects, and remote-controlled circuits. It is small, low-cost, and very reliable for wireless control using infrared light.
You can control the left and right flow of turn signals using a simple toggle switch. Start with a 595 shift register chip. Connect pin 8 to pin 13 and pin 10 to pin 16. Solder a 10 kilo ohms resistor between pins 14 and 16. Next, use an 8050 transistor. Connect the emitter to pin 13 and the collector to pin 14. Add a 10 kilo ohms resistor between the base and pin 9. At this stage, the circuit is halfway complete. Now set up an NE555 timer in a stable mode to generate pulse signals. Connect the power supply pins of the NE555 and the 595 together. Pins 1 to 7 and pin 15 of the 595 act as outputs. Connect these to your LEDs and arrange them into 2 rows for left and right indicators. Solder the negative terminals of each LED row to the 2 outer terminals of a 3-position toggle switch. Connect the main negative wire to the center terminal. Power the circuit with 3.7 volts to 5 volts. Once switched on, flipping the toggle left or right changes the flowing direction of the sequential turn signals.